Hey, good evening, my friends. Welcome back to the sprint for grade 12 board exams. Today is day 6, and I'm sure you enjoyed the past 5 days of this sprint. If you have not seen those lectures and videos, please go back and see them after the class today. So this is Bhavdeep Singh. For the students who are new here, this is Bhavdeep Singh. I'm a master teacher here at Vedantu. I have been teaching all the board exam classes here for the sprint, and this is the schedule. You might have seen that, and today is day number 6. So we are going to cover alternating current and electromagnetic waves. A very exciting topic, by the way, because so far up to grade 10th you have studied direct currents. You have not studied alternating currents in detail. In addition, electromagnetic wave itself is a big, very interesting phenomenon. I don't know, many of my students actually they say, sir, yehi padha do. Electromagnetic waves is a very interesting and marks bahut scoring hai, because there's nothing much to study in that. You cannot lose marks in that. So make sure you focus on these two chapters as well. But before we start the session, just a quick reminder, you have to please do subscribe to the YouTube channel here and press the bell icon so that you can get notifications about the future courses, and we have so many planned so please do press the bell icon. In addition, please share the YouTube channel with your friends and relatives, classmates, and whoever you want to help out for. Tell them there is free education here, and we are really excited to help you out. Please do share the YouTube channel with whoever you want to help out. Now, strategy as always is going to be simplification here, right? So anything that you thought कि भाई इतना मुश्किल है, derivations इतने मुश्किल है, कैसे याद करने हैं, 2 पेज का derivation है, we are going to simplify that. No derivation, किसी भी derivation की approach जो है, that should not be more than 5 lines. Approach कह रहा हूँ, you will have to present it in 2 pages maybe, but the basic thing, thought process behind that should not be more than 5 lines of your writing. जो rough में करके scribble करके देखना है. So we are going to simplify anything you thought was difficult. So that is the strategy here. So why board exams? And I have been talking about it in past 5 classes also. Board exams are very important because 75% marks are needed if you're thinking of IIT, NITs or centrally funded institutes for engineering. For medical exams, 50% in physics, chemistry, biology. And by the way, that 75% can also be 20 percentile if your board does not give marks, it does not give percentage but gives percentile. But in addition to all this, the main reason is to clear concepts. Board exam में हम लोग क्या करते हैं? We do derivations, we do lengthy analysis and all that, and that actually helps you understand the concepts. With competitive exams, you're just looking for the multiple choice thingy. You can use elimination method, you can use shortcuts and all that. So many times you do not go into the details of many things, and trust me, this is going to help you in the long run understanding concepts. So please do give enough importance to the board exam, not just for the sake of passing, for the sake of learning physics. Even if you're not taking physics as a major in your colleges, no worries at all. This is going to help you in your life. I'm telling you, you're going to use physics sometime in your life. So let's see the agenda. आज का क्या agenda है? आज का agenda है alternating currents plus this awesome behavior of electromagnetic radiations. पूरे रूम में भरी हुई है यार. लाइट है यहाँ पर, देख रहे हो, है ना? मोबाइल सिग्नल्स, रेडियो सिग्नल्स, टीवी सिग्नल्स, सारे electromagnetic radiations. This room is full of electromagnetic radiations. You're sitting between those radiations. You cannot see them. Now, as always, board exams में derivations very important. Derivations not important just for the board exams. They're also important to understand the concepts. When you derive things, you see what's going on behind the scenes. When you memorize formula, you do not see पीछे हो क्या रहा है. So derivations number 1 priority, please. NCERT back exercises. All the questions, no solutions has to be referred. अगर solution refer करो, you're trying to memorize those. So try to do all back exercises yourself. If you need help, Vedantu.com has all the solutions for you. But try to solve them yourself and then try to match the solution maybe. Additional exercises which are a little more should also be done. All the back exercises अगर कर ली तुमने सारे chapters की yourself, guaranteed यार तुम्हारा क्या score कोई रोकेगा. Past question papers at least 5 years के बोलता हूँ मैं, but more than that, more the merrier. But at least 5 years के question paper, the biggest mistake students make is they refer to the solutions for the past year question papers. Do not do that. Take the question paper, try to solve it yourself the way you're going to solve it, and then refer to the marking scheme or solutions to make sure that what you have done matches the expectations. Vedantu.com has the solution and the question papers over there. So that is where one-stop shop anyways. तो पहला क्वेश्चन यहां पर आ गया, why is that a pure inductor not used to control a direct current? Now what is inductor? We have done that in the past also. Inductor क्या है basically? है ना? One more question, you don't have to explain all this, but you have to explain all this to yourself before you can answer it. Inductor आ गया इंडक्टर. इंडक्टर हेट्स एनी काइंड ऑफ चेंजेस. इसको मैंने डायरेक्ट करंट दे दिया, लेट्स से डायरेक्ट करंट, एक बैटरी लगा दी, एक स्विच लगा दिया, वेरी रफ रॉ काइंड ऑफ सर्किट ओवर देयर. स्विच इज ओपन. अब स्विच को जैसे ही क्लोज करा, व्हाट्स गोइंग टू हैपन इज देयर इज अ चेंज. व्हाट इज द चेंज? देयर वाज नो मैग्नेटिक फील्ड लाइन इनसाइड ऑफ इट. नाउ देयर आर मैग्नेटिक फील्ड लाइंस इनसाइड ऑफ इट. इट डज नॉट लाइक इट, सो इट्स ट्राइंग टू क्रिएट opposing EMF कि नहीं रुक जाओ, I don't like a change, but eventually it's going to give up and eventually all the current is going through go through that. तो शुरू में hesitate करेगा, नहीं change चाहिए, and then eventually it gives up. So this one is going to let the direct current pass through. ठीक है. Alternating current में problem हो जाएगी, क्योंकि alternating current में when it is getting used to in this direction, think about the inductor. So let's say you have the same inductor, and I'm just trying to teach you the concept here first. Question तो तुम कर लोगे, है ना? स्विच लगाना है लगा दो, मर्जी है, ठीक है. अब क्या करा? Current is trying to go in this direction. Initially it's trying to say no, stop, and then it is trying to get used to that. But by the time it has got used to that in this direction, you're saying no, the current goes in this direction. I changed my mind, and then it says no, wait. So what's happening here is ऑल्टरनेटिंग करंट में प्रॉब्लम होगी. और मोर द फ्रीक्वेंसी द मोर द रेजिस्टेंस, बिकॉज जैसे ये यूज टू हो रहा है, you're changing it, है ना? सो हायर द फ्रीक्वेंसी, हायर द रेजिस्टेंस ऑफर्ड बाय दिस. इसमें तो फ्रीक्वेंसी जीरो है, तो इट इज गोइंग टू से ओके जाओ यार. सो यू कैनॉट कंट्रोल अ डायरेक्ट करंट विद एन इंडक्टर. दैट इज द मेन रीजन, दैट इज द ओनली रीजन रादर. सो लेट्स सी हाउ यू कैन राइट इट इन द एग्जाम. It does not offer any resistance to direct current. ठीक है. अब formula, maybe you are a formula person, because many students go by formula. Now look at this. Inductive reactance क्या होगा? Omega N. Now when omega is 0, for direct current omega is 0, so this is 0. It does not offer any resistance to the direct current. Now this is not related to this question, but think about capacitive reactance. 1 by omega c. If you are a formula person, you can see that if this is omega is 0, ये infinity, है ना? This goes a very high value, and that is why when you have a capacitor connected to direct current, initially तो charge हो रहा है, and then it's an open circuit. It's more like an open circuit. But if omega is more, ये resistance offer करेगा, ये नहीं करेगा, क्योंकि if omega goes more, this is less. ठीक है. So go by the simple understanding of these concepts. Memorize कुछ नहीं करना. Physics में memorization will not help you. Now for a circuit used for transporting electric power, a low power factor implies a large power loss in transmission. Is this statement true? Before you start solving it or presenting it in the exam box, you think ho kya raha hai? What is power factor? So let's think about it. So here is a picture of real power, reactive power. What is reactive power? The power which is given to the capacitor or inductor. But remember, what do? When you have an alternating current, So let's think about it for a while. I'll pause the video here. Not pause the video, but the slide screen here. So let's say you have this capacitor. ठीक है. इसमें alternating current दे दिया, है ना? इसमें ये दे दिया. I'm just trying to explain the concept here. Now there is a lot of power going in, but some of the energy is stored here as electric potential energy. In the reverse cycle, that is coming back. है ना? Apparently it look like बहुत सारी पावर जा रही है, बट वो पावर कुछ तो यहाँ हीट में जा रही थी. हीट में कौन सी जा रही थी? ये जा रही थी रियल पावर, हीट में जा रही थी, और कैपेसिटर में स्टोर हो रही थी ये पावर. तो ये पावर यूज नहीं हो रही है. ये एक्चुअली रिएक्टिव पावर है. दिस इज नॉट द रियल पावर. इट्स गोइंग एंड देन कमिंग बैक, गोइंग एंड देन कमिंग बैक. सेम गोज विद इंडक्टर्स. दिस स्टोर्स इलेक्ट्रिकल पोटेंशियल एनर्जी. इंडक्टर विल स्टोर इट एज मैग्नेटिक पोटेंशियल एनर्जी. वो स्टोर कर रहे हैं और फिर वापस कर रहे हैं, है ना. So what is happening now? This is the real power that is being dissipated there, and this is the reactive power here. But this is the apparent power. तुमको इतनी देनी पड़ रही है बैटरी से. Now there is a problem because if there is a transmission line को तुम ये दे रहे हो अगर transmission line, what is transmission line? The overhead power lines over there. वो क्या करेंगे? They are going to dissipate some of the energy as heat. You have already seen that in grade 10th कि I square RT is going to be lost as heat in these wires. तो इसको रिड्यूस करने के लिए क्या करते हैं? एक चीज हम क्या करते हैं कि वोल्टेज अप कर देते हैं, राइट? स्टेप अप ट्रांसफॉर्मर, बिकॉज व्हेन यू डू दैट दिस रिड्यूसेस, राइट? बिकॉज पावर इज कांस्टेंट. तो जब ये कम हो जाता है तो I square RT पावर लाइंस में कम हो जाती है. ठीक है, वो तो हमने कर दिया. बट अब प्रॉब्लम ये आ गई, बिकॉज ऑफ दिस थिंगी यू आर सप्लाइंग मोर करंट बिकॉज दिस इज द रिक्वायरमेंट, बट दिस इज द apparent one you have to supply, but this is being lost here. So your goal क्या होना चाहिए? तुम्हारा गोल क्या होना चाहिए? ऐसे समझो, this is the real power that you need. This apparent power should be like equal to that. ये थीटा कम चाहिए हमको थीटा जितना कम होगा उतना ज्यादा अच्छा है, right? Because if let's say theta is 0, then apparent power is actually equal to the real power. जितना ये theta ज़्यादा होगा उतना bad है. Now what is power factor? Power factor is the cos theta here. Power factor is basically the real power divided by the apparent power. So cos theta की बात हो रही है. तो अगर ये cos theta कम है, कम कब होगा? जब ये theta ज़्यादा होगा. तो अगर ये कम है तो इसका मतलब कि पावर तुम्हारी ये apparent power ज़्यादा है compared to this, because ठीक है, power factor is this divided by this. If power factor is less, then this means this number is more compared to this and you're losing so much. So this ये जो statement है वो right हो गया. Let's see that. And this is how you're going to write it. It was a 1 mark question. Yes, it was a 1 mark question. So this is how you're going to present it in the exam. And again, as I said earlier also in all my classes earlier, these are the sample responses. You do not have to memorize them. Try to understand the concepts. Present it in your own words using your own vocabulary and grammar. Memorization is not going to help in physics. So let's go to the next question. Which electromagnetic radiation is used for water purification? ये तो day to day है. That's what I was saying. Physics is going to help you in your day to day life. What do you use? Ultraviolet, water purifiers, UV purifiers, right? Ultraviolet purifiers. तो ये तो पढ़ने की ज़रूरत ही नहीं है. When you read your product manuals, when you see the labels on your water purifier, you might have seen ultraviolet, eye surgery, infrared. I mean, these are the things that you see in your day-to-day life. These are not even something you have to study and memorize. ठीक है, 1 mark सीधा देखो कितना 1 mark का question है, but then that needs no study. Do electromagnetic waves carry energy and momentum? What is a wave? Wave actually carries energy and momentum from point A to point B. That's what the wave is. कोई भी wave ले लो, sound wave, water wave, rope wave, यहाँ पर energy है, it's taking this energy and momentum to this point. Wave is all about transfer of energy and momentum. So why would electromagnetic waves be any different? These are carrying the energy and the momentum. तो देख लो एक बार. Energy you already know is h times the frequency and the momentum is, ठीक है, बस ये एक, I think this was also 1 mark question. Now, draw the label diagram of a step down transformer. State the principle of its working. है ना, बहुत कुछ इसमें पूछा है, लेकिन ये 3 मार्क का क्वेश्चन है. तो स्टेप बाय स्टेप करते हैं. पहले तो ट्रांसफॉर्मर देख लेते हैं. इसमें ट्रांसफॉर्मर की बात है, होता क्या है. पहले अंडरस्टैंड करो कि होता क्या है ना. मैनी स्टूडेंट्स डू नॉट अंडरस्टैंड कि भाई फर्स्ट ऑफ ऑल व्हाई डज ट्रांसफॉर्मर ओनली वर्क विद ऑल्टरनेटिंग करंट, वो भी पता होना चाहिए. ये कॉइल ले लिया मैंने, दिस इज अनदर कॉइल. You make a current go through this coil, right? So when the current goes through this coil, think of a solenoid. This is a magnet now. So there is a magnetic field coming out of it. That magnetic field is linked here. This is mutual inductance happening, my friends. 2 coils, mutual inductance. So ये इस पे I am supplying the current here. So when the current flows through this wire, this loop, there is a magnetic field here. Some of that magnetic field is going through this, some of it, है ना. We are trying to maximize that by using all this core and all that, but let's say all of it goes through this. हो गया, कौन सी बड़ी बात है, इट्स नॉट अ बिग डील। यहाँ पे करंट जा रहा है, यहाँ पे फील्ड आ रहा है, व्हाट्स अ बिग डील। बट नाउ थिंक अबाउट इट, if this current was alternating current, this current is continuously changing, 0 to maximum to 0 to minimum to 0, है ना, it's a cycle, sinusoidal wave. So if this was an alternating current, this field was changing, the field coming out of this was changing. If the field coming out of this was changing, the field going into this was changing. Now there is something that will happen. This coil says I am an inductor. Now think of this as an inductor. This will say I'm an inductor and I do not like any kind of change. Change is happening. So it is going to create a back EMF to oppose that. And that back EMF makes the current go through this. पूरी cycle समझो इसकी. And then you can write it down. कोई memorization नहीं, nothing. So there is an alternating current going through this. That alternating current changes the field coming out of this. That change makes the field going into this change. This coil says I do not want the change, so I'll create a back EMF, and that induces a current here. तो करंट तो यहाँ पे ये ऑल्टरनेटिंग करंट यहाँ लगा रहे हैं, बट यहाँ भी हो रहा है, यहाँ पे एक बल्ब लगा दिया, बल्ब इज गोइंग टू लाइट अप। नाउ फर्दर टू दैट, assuming no power loss, law of conservation of energy says energy can neither be created nor destroyed. ठीक है, it can be lost, है ना, made as converted to heat and all that. But let's say ideal scenario, nothing is being lost. So whatever is energy here or the power here is the power here. ठीक है, now फॉर्मूला पे मैं नहीं जा रहा, बट दैट शोज यू कि अगर यहाँ पे कॉइल्स ज्यादा हैं और यहाँ पे कॉइल कम है, तो you can see that power is same, so the voltage here will be less. So basically what will turn out to be is this. ये मैं next slide में दिखा दूंगा कि अगर यहाँ पे voltage, so basically what you'll end up getting is number of coils in secondary by number of coils in primary is same as voltage in secondary by voltage in primary. Now because power is same, voltage, देखो power क्या होता है, power is वोल्टेज टाइम्स द करंट। अब पावर इधर इधर बराबर है, तो वोल्टेज और करंट इनवर्सली प्रोपोर्शनल, तो ये हो जाएगा तुम्हारा करंट इन प्राइमरी बाय करंट इन सेकेंडरी। ये सिंपल सा कॉन्सेप्ट है ट्रांसफार्मर का। नाउ यू कैन प्रेजेंट इट इन 1 पेज 2 पेज और यू कैन राइट 1 फुल बुक ऑन दैट। सो लेट्स सी दैट इट इज बेस्ड ऑन द प्रिंसिपल ऑफ इलेक्ट्रोमैग्नेटिक म्यूचुअल इंडक्शन। मेक श्योर दिस इज नॉट सेल्फ इंडक्शन, दिस इज म्यूचुअल इंडक्शन, 2 coils. So I'll let you read or take a screenshot if you want to. Now once you understand the concept, ये सारा बनाना and then you can present it as many based on the number of marks and all that. ठीक है, third वाला question numerical था, I'm going to make you do that. So let's see the next question here, and I'll let you read the question first. There are 3 parts and it's 3 marks. तो पहले तो they are talking about transformer. What is a transformer? So here is the transformer. And many students think, oh, NP, NS and all that, क्या करना क्या है? First of all, you understand what is a transformer. एक coil, 2 coil. ठीक है? This is called the primary, this is called the secondary. Primary coil में सब current दिया. So there is a current flowing through the primary coil. Think about solenoid. This is a solenoid. So when the current passes through this coil, this becomes a magnet and there is a magnetic flux. There is a magnetic field coming out of this coil. Now, field coming out of this coil will pass through this coil. Now, obviously some of the field will go and it's not, so point is maybe not all of the field lines coming out of this primary go into this, but we have this core and we try to make sure that the maximum number go through that. For simplicity we'll say every field line coming out of this goes into this. Let's start with that. तो start over करते हैं. So there is a coil here, there is a current through that. Think about a solenoid. So this becomes a magnet. Now if this is a magnet, there's a field coming out of this. If the field lines are coming out of this, they're going into this. हो गया. But now again think about this. If this current that I was passing here was alternating current, what that means is the current keeps changing in this coil. The field strength is, remember in the case of solenoid, mu naught times N times the current. If the current itself is changing, the field here is changing, that means the number of lines coming here is changing, that means the number of lines going here are changing. But think about this blue wire as a inductor now. This inductor says if you're changing the magnetic field, I'm not going to let you do that. So it produces a back EMF and it says I'm trying to oppose the change you're doing. So what that EMF will do, that will make a current go through this. This will flow a current. यहाँ पे एक bulb लगा दिया तो bulb light up हो जाएगा. So in short, we are passing the current here, alternating current that generates or induces an alternating current here. That is the transformer. Further to that, energy can neither be created nor destroyed. It can be wasted as heat or whatever. We are assuming for simplicity, it's a 100% efficient machine. No energy is lost. Power here, power here. With that, actually, we don't have much time, but with that, what you're going to get is this simplified version. Okay, number of coils in primary divided by number of coils in secondary will be equal to voltage in primary is by voltage in secondary. Now, power here, same. Power is voltage times current. Current और voltage inversely proportional. तो अगर VP by VS है, तो ये IS by IP हो गया. And that is all. That is the principle of transformer. अगर ये coil ज़्यादा है, तो voltage here is more, voltage here is less. That becomes a step down transformer. If the coils here is more, then the voltage here is more, it was less, so it becomes a step up transformer. That is all. And you can present it yourself in your own words. I'll let you see that. Now once you understand the concept, based on the number of marks, you can present it in 5 lines, 10 lines, 1 pages or whatever. Right? So here is just a sample, and I'll do the numerical also with you. So let's go through the numerical. I'll pause here. Yeah. So how much current is drawn by the primary of a transformer? So just make a rough sketch. Before you start doing it, make a visual. You don't have to be very pretty in making this. Just make a picture and see what's going on. This transformer is connected to 220 volts. Now, this is supplying power to a refrigerator. There is a refrigerator here. Single door, double door, doesn't matter to you. There is a refrigerator and it is taking 110 volts, 500 watts. They are asking how much is the current here. So, how much current is drawn by the primary? The goal is how much current here. There are multiple ways you can do that. You can find the current here, then use that relation NS by NP and all that. But why do that? It's much simpler than that. It's much more simpler. 500 watts here, 500 watts here. 100% efficient machine. They have not said it. I think it was 550 watts. So I'll modify that. So that is actually 550 watts, and that's actually good because it is going to be divisible by this 220. 500 से मुझे थोड़ा सा ज़्यादा effort करना पड़ता. See how easy they have made the calculations for you. 550 watts. But anyway, this is 550 watts, and they're not telling you the efficiency. You can assume if efficiency is not given, the machine is 100% efficient. So 550 watts here, 550 watts here. खत्म. तो यहाँ लिख दो. यहाँ भी 550 watts, and you're supposed to write it because this is an ideal transformer. It is 100% efficient. That's what I'm assuming. बस अब तो हो गया यार. Power is equal to voltage times the current. तो 550 by 220, 2.5 amperes आंसर आ गया. ठीक है. अब उसको प्रेजेंट कैसे करना है, that's completely up to you because you have to use your own language, your vocabulary, your grammar, but this is a simplified version of the solution. That's all. Next question here. What is electrical resonance? Resonance, उससे कुछ याद आ रहा होगा resonance से. Resonance क्या होता है? Oscillations, grade 11th. There is an oscillation. Resonance, I bang on this table, it vibrates with a natural frequency. Now you try to make it vibrate with a forced frequency, forced vibration. But when the frequency of forced vibration matches the frequency of natural frequency, that is resonance, and there is going to be high amplitude. वो देखा होगा ना, like I don't know, you might have seen those. So glass windows, they vibrate when there is a music played, the boom boom sound, or maybe when a jet plane flies close to that. So that is all resonance. When the frequency of vibration of the glass matches the forced vibration. Same thing here, no difference at all, right? So we don't have much time. If it was a regular class, I would have taken a pendulum and compare that pendulum. So basically this is what I do in my regular classes, and you should do it as a homework now. Take an inductor and a capacitor, a charged capacitor. This is no different than a pendulum. Pendulum को 10 swing किया, potential energy, electrical potential energy. वापस आया, काइनेटिक एनर्जी ही तो है, ऑल दैट चार्जेस आर मूविंग हियर, full enthusiasm with full current, they don't want to stop, that is inertia. Because of inertia it keeps going, here, and then it goes to the other way, charges other way aa gaya pendulum, and then it starts going back, and then full energy is kinetic energy, potential energy, kinetic energy, potential energy, kinetic energy. This is a pendulum, right? So try to analyze this yourself, we don't have time for that, but let's see what we can do here. So here is a circuit, LRC, राइट. सो कंडक्टर भी है, सॉरी कैपेसिटर भी है, इंडक्टर भी है, रेजिस्टर भी है. तो इसमें क्या कर सकते हैं, रेजोनेंस की बात हो रही है. तो इसमें अगर तुम देखो, एक और डायग्राम है मेरे पास, हाँ, दिस विल हेल्प एक्चुअली. सो इफ यू थिंक अबाउट इट, कैपेसिटिव रिएक्टेंस एंड इंडक्टिव रिएक्टेंस दे आर उल्टा है ना, एक ऊपर जा रहा है एक नीचे रहा है, 180 डिफरेंस होता है. तो उन दोनों को वेक्टर्स को मैंने ये ऐड कर दिया. यू माइट हैव ऑलरेडी डन दिस, एंड दिस इज रेजिस्टर एंड दिस इज द इंपीडेंस. दिस विल प्ले द रोल ऑफ V is equal to IR पे R की जगह रखेंगे. This is the net effective resistance to the flow of energy over there. So this plus this, as in Pythagoras theorem, is this, and this is what you're going to plug in there. तो उससे तुम्हारा क्या आ जाएगा, उससे तुम्हारा ये आ जाएगा V, इसको लिख देते हैं यहाँ पे, इधर लिख देते हैं. तो V इज इक्वल टू आई आर, है ना. आर को मैं यहां नीचे ले आता हूं. आर क्या हो जाएगा, दिस पाइथागोरस थ्योरम. सो आर स्क्वायर प्लस एक्स एल माइनस एक्स सी का होल स्क्वायर. सो लाइक व्हेन आई वाज सेइंग, ओके, द विंडो वाइब्रेट्स faster when the natural frequency matches the forced vibration, that is more oscillation. That's the same thing. When will you have the most current? जब ये फैक्टर जीरो हो जाएगा, है ना, क्योंकि इस चीज को मिनिमाइज करोगे. इफ द डिनोमिनेटर इज मिनिमम, द होल थिंग इज मैक्सिमम. हाउ कैन यू मेक दिस मिनिमम? ये पॉजिटिव है, ये थिंग भी पॉजिटिव होगी या जीरो होगी, इट कैन नेवर बी नेगेटिव. सो मिनिमम इट कैन हैव इज जीरो. हाउ विल इट बी जीरो? इट विल बी जीरो व्हेन XL माइनस XC इज जीरो और XL इज इक्वल टू XC. इतना सिंपल है ये. XL क्या है, ओमेगा L. XC क्या है, 1 by ओमेगा C. Cross multiply, the frequency is equal to 1 by root of LC. This is the natural frequency of this. If you have this alternating current with the same frequency, it will be oscillating with full enthusiasm. This is exactly what we were talking about earlier. ठीक है, तो this is the natural frequency of this circuit. If you can make sure that you take this frequency and make the alternating current have the same frequency, it will have the maximum current go through that. So let's see how we can present it all this in the exam. एक बार समझ में आ गया, then you can write it in your own words here. है नहीं simple? ठीक है, let's see the last question for tonight. This is the last question. So a device X is connected. The current through X is given like this. Bhai, yeah, this is, look at the equation there and then think about it. अगर रेजिस्टर होता तो वोल्टेज एंड करंट आर इन द सेम फेज. करंट आगे है, करंट आगे है किस में होता है, इंडक्टर में कि कैपेसिटर में. इफ यू डोंट रिमेंबर दिस, यू डोंट हैव टू मेमोराइज. बाय द वे, थिंक अबाउट कैपेसिटर हियर. कैपेसिटर है, इसको मैंने यहाँ पे पावर देनी स्टार्ट की, मैंने एक बैटरी लगा दी. इलेक्ट्रॉन स्टार्ट्स कमिंग हियर, है ना. इलेक्ट्रॉन यहां से आया एंड इट मेक्स दिस नेगेटिवली चार्ज्ड. फिर फुल एंथुसियाज्म आया, है ना. एंड देन बिकॉज दिस इज नेगेटिवली चार्ज, वन ऑफ द इलेक्ट्रॉन रिपेल्स फ्रॉम हियर. ये पॉजिटिव हो गया. अनदर इलेक्ट्रॉन आया, अनदर इलेक्ट्रॉन चला गया. तो व्हाट इज हैपनिंग इज इलेक्ट्रॉन्स आर रनिंग एंड ट्राइंग टू चार्ज इट विद फुल एंथुसियाज्म. But as the electrons are charging this, there is a potential that is being built up here. Remember, the potential was zero initially and the potential is increasing. As the potential is increasing, the next electron that comes in, these repel. They say, nahi, वापस जा भाई, है ना. So what is happening now? All those electrons that were going with the full energy, full speed there, they're going to reduce down to zero. So current में क्या हो रहा है? Current तो maximum से zero में जा रहा है. Potential zero था और वो maximum में जा रहा है. तो current ज्यादा, it's पाई बाय 2 अहेड ऑफ द वोल्टेज. थिंक अबाउट एनालाइजिंग दिस वे. और उसमें उल्टा करना पड़ेगा तुमको. I'm just giving you pointers that you can do after the class. Do not end, do not sleep. Wait for 30 minutes, try to analyze whatever I have said today. तो ये जब मैंने लगाया तो इनिशियली बैक ईएमएफ फुल वोल्टेज देयर, जीरो करंट, इनिशियली जीरो करंट, क्योंकि उसने पूरी एनर्जी से रोक दिया. लेटर ऑन करंट स्टार्ट्स बिल्डिंग अप, वो करंट इंक्रीज हो रहा है और वोल्टेज रिड्यूस हो रहा है. इस केस में वोल्टेज लीड्स, इस केस में करंट लीड्स. कैपेसिटर में करंट लीड्स, उसमें वोल्टेज लीड्स. अब ये करंट लीड्स है तो ये कैपेसिटर है, हो गया. इसमें तो कोई सोचना ही नहीं है. आइडेंटिफाई द टाइप ऑफ द डिवाइस. दिस इज अ कैपेसिटर. राइट द एक्सप्रेशन फॉर हिज रिएक्टेंस. रिएक्टेंस क्या, वी हैव कवर्ड इट इन टुडेज क्लास, 1 बाय ओमेगा सी. ड्रॉ द ग्राफ्स, ये कर लो बेस्ड ऑन व्हाट आई सेड. हाउ डज द रिएक्टेंस ऑफ द डिवाइस वेरी विथ फ्रीक्वेंसी ऑफ द, ये कर देते हैं एक बार. कैपेसिटर की बात हो रही है. कैपेसिटर इज 1 बाय ओमेगा सी. नाउ थिंक अबाउट डायरेक्ट करंट. डायरेक्ट करंट में ओमेगा 0, so this is very high because एक बार वो चार्ज हो गया then it is broken circuit there. But if omega increases, this reduces, so it's going to love more and more frequency, है ना. It is going to let pass. अगर फ्रीक्वेंसी ज्यादा है ऑल्टरनेटिंग करंट की तो ये कम देगा उसको ऑपोजिशन. सो इट्स इनवर्सली प्रोपोर्शनल. शो दिस ग्राफिकली. ये तो यार ग्राफिकल प्लॉट तुम कर ही लोगे, इसमें क्या करना है. एसिम्पटोट्स हैं वो. एज दिस अप्रोचेज infinity, this approaches 0. As this approaches 0, this approaches infinity. तो asymptote हो गया vertical and horizontal. ठीक है. So let's see how we can present this in the exam. ये सब तो तुम, ठीक है, once you understand you can always write all this. फेजर डायग्राम. फेजर डायग्राम क्या, करंट इज लीडिंग द वोल्टेज. ये वोल्टेज है, ये करंट है, करंट आगे है बिकॉज वी आर रोटेटिंग एंटी क्लॉकवाइज. दैट्स अ पॉजिटिव डायरेक्शन. अगर ये इंडक्टर होता तो करंट इधर होता, वोल्टेज वहां होता. So that's all for today. I'll see you tomorrow same time, and I'm sure you have already subscribed to the channel. If not, please do subscribe and press the bell icon so that you can get information about the upcoming awesome courses designed here. Please share this information with your friends so that they can know about the free education here. Also, make sure that you download the app, because on that app you are going to get all these slides for today as a PDF. So make use of that. I'm going to see you same time tomorrow. Until then, thank you. Good night. Bye bye.